Okay, welcome to the JavaScript presentation workshop on data science. I am a math computer science major, third year at UCSD. I've done some industry work as well as taken some classes on JavaScript and machine learning. So here to give you a little tutorial, and then at the end, we'll kind of go over some data visualizations in JavaScript. First I'll cover what is JavaScript, then I'll go through the different syntax, variables, and eventually we'll actually create that data visualization in the browser. So, right off the bat, in case you've never seen or used JavaScript at all before, the definition straight for the Mozilla documentation. It's a scripting language that allows you to implement complex features on the web. So that includes a ton of different updates, interactive features, graphics. Yeah, welcome in. Scrolling or different features like that. So when you're doing web programming, JavaScript is where you add this more complex functionality and maybe communicate with databases and stuff like that. So to start off with JavaScript, go over the variables. There's three different ways you can declare variables in JavaScript. There's let, var, and const. So let declares a variable that is called block scoped, which means that variable only exists within the nearest set of curly braces. So if you look on the left here, if we make a variable num and set equal to 10, then we enter this if statement, which is true because 5 is greater than 4. When it sets num to 8 inside here, that variable is limited to the block of the if statement. So once you exit the if statement and you print out num, your output is actually 10 because this value disappears from memory after you exit the if statement. Var is a bit different because that's function scope. So once you go inside the if statement, it actually keeps that value after you leave the if statement. And so then the output becomes 8. And console log is just the way to print in JavaScript. Since everything's typically run client side in the browser, you just print things out to the console in someone's web browser. And the third type is a const variable. It's block scope, just like a let variable. So you'll see when you go in the if statement and create a new variable num that's 8, and then you console log num outside the if statement, it's still 10. However, if you try to reassign already existing variable, like here and set it to 7, you'll get an error because const variables can't be reassigned after they're declared. Any questions on that? And then I just wanted to go over some of the most common data types in JavaScript. I'm sure you've seen a lot of these before. There's string, we have numbers. If you tried to print out a variable or variable name that you haven't declared yet, it'd come up as undefined. There's Booleans in JavaScript, true and false. And there's classic objects where you have a key value pair. There's null value in JavaScript, which if you were to print out the type, it prints out object because null is an object in JavaScript. Welcome in, grab a seat. And then there's also lists and different data types like that. And when you print the type of those data, they always come out as objects. Quickly go over a couple of the operators too. So, there's simple addition, 1 + 2 is 3. Hi, welcome in. And if you try to combine different data types, JavaScript will automatically decide how to combine those based on the expression that you write. So if you try to add 6 and 4, where 6 is a number and 4 is a string, it assumes you're just concatenating two strings. So it's going to turn it into 64 and just place them side by side. Whereas if you use the subtraction operator and do the number 9 minus the string 2, it's going to say, okay, they probably want these to be numbers. So it'll actually result in the correct number 7. And another one, JavaScript gets a bit quirky here, is if you do 5 times the string 3, this one also does work, and it will treat them just like real numbers instead of like strings. Another weird thing is true is actually stored as a 1 and false is stored as a 0. So if you try to do 2 minus true, you'll assume you're doing arithmetic with numbers. So actually convert true to the integer 1. So 2 minus true will actually output to 1. And one more operator, there's the AND operator. I'm not sure if anyone's familiar with bitwise operations, but 4 and 3 basically does an AND operation on these two numbers, which results in 0. And then there's the logical OR. I know these are not all the operators, but just kind of giving you an overview of most used ones. True or false, of course, evaluates to true. Yeah. If 5 was a string and 3 was an integer? let's see. What's fun about JavaScript is, I don't know this off the top of my head, but there's a lot of cool places you can just type it right in. So let's see. Console.log, and you're saying 5 is a string and 3 is an integer. Let's see what that is. So that would also be 15. Yeah, I know it can be kind of quirky, so it's always a good idea to just, just like you did there, just try it and see what happens. All right. So get it back. Perfect. All right. Any other questions on operators?
Yeah. When you concatenate 6 and 4 and it gives you 64, it gives that back to the string.
Correct.
So, and then
Ooh, actually, then I think no, sorry, it would evaluate as a number because assuming that 6 and let's see. When in doubt, search it up, right? Instead of answering. So if we were to do 6 plus 4, and we were to take the type of that value. Right, it'd be a string because it's concatenating them as a string instead of adding them as numbers. All right, any other questions on there? All right. Hi, welcome in. All right, so moving on to the next slide, we have some basic loops. So there's the while loop. So we're going to set variable I equal to 0. And while I is less than 10, we'll console log or just print out the variable I to the console. And then increment I, the I++ just increases the value of I by 1. So running this code right here will just output the integers 0 through 9, line after line. And then this for loop here will do the same thing. You declare the variable I equal to 0, go until I is less than 10, and increment it at the end of each loop. And you'll also end up with the same output of the integers 0 through 9. Another cool loop in JavaScript that maybe not as many people use is the for of loop, which is really useful. If you have an array or a list, instead of having to define the indices from 0 to the length of the array, you can just say, if you have the array over there, for example, for const num is just a generic name you're declaring for each number in the array. And you print out that number, and that'll have the same output as integers 0 through 9. So basically that loop in each iteration will set for 0 equal to num, then num equal to 1, num equal to 2, and so on. All right, any questions on loops? So I have a quick question for you guys, just to check understanding. If we were to run this code here, where first we declare the variable I be equal to 1, and while it's less than 10, we log it out to the screen, and then this operator right here just means I equals I times 2. So it just doubles the value of I. So can anyone tell me what the output of this code would be? Feel free to take a second, or let me know whenever you're ready. Or if anyone wants to just work through it, explain with your thought process, any ideas? All right, how about what's the first number to be printed? 1, right? And then in the next iteration, what would it print? Yeah, and then the last one? 8, right. And then it would, after it prints 8, it would double it to 16, and then the last time coming in, 16 is greater than 10, so it would stop the loop. All right. Then we get into JavaScript functions. So you wanted to declare a function that adds 2 numbers. You would do so with the syntax up above. Takes in the 2 parameters, num1 and num2, and then just returns the sum of num1 and num2. Notice JavaScript is loosely typed, so you don't have to declare the types of those variables. So you might want to make sure that those are numbers and you're not actually going to be just concatenating strings or something like that. And then, for example, if we were to call add 2 numbers with the parameters 5 and 7, it would give us output 12. So another question for you guys about functions. If we had a function increment by 2, which takes an input parameter num, adds 2, and then returns num, and then we were to run this code below, where we call increment by 2 on the value 4, we store the return value in num, Then we call increment by 2 on that variable. And then we log it out to the screen. What would be the output? And this one's a little bit more tricky, so feel free to take a sec. And ask me if you have any questions or want any clarifying questions. Feel free to talk about it with your person next to you too, if you guys want to discuss it together. Good. Exactly. Can you explain, just how you got there, maybe line by line, what it would be here and then what would be at the end?
Putting in the function, adds to.
Right?
Numbers equal to 6 now.
Right.
And then the next call, the function isn't stored as anything.
Right. Perfect. Yep. That was a big thing. Just noting that, just like you said, once it adds 2, you get 6, stores that here, but then this call doesn't actually save the return value anywhere. So the none just remains at 6. All right. Any questions on that? All right. So now I have a little thing you can all do on your own computers, and then we'll come back and look at it together. I want you guys to write a function that takes in a list of numbers, and I want you to return a new list of all the numbers that are greater than 10. So just the one syntax I got to give you, because I didn't show you how to add a number, add to a list of numbers in JavaScript. If you have a list, you just call dot push with a number, and that'll add something to the end of the list. Besides that, you should have all the tools from the first couple of slides to create this function. So I'll give you all a couple of minutes to write this on your own computer, and then I'll bring up an example and we can see how it all matches. Any questions on starting this? And feel free to work together, please talk to the person next to you, see what they're doing. Just to go over, the example input, if you did take in a list and the numbers were -5, 4, 67, 44, 3, and 10, it would output the list of 67 to 44. So obviously those are the only 2 numbers greater than 10 in the list. Important to note that it doesn't return 10 because 10 is equal, not greater than 10. I'll give you all another couple more minutes to work on that. Does anyone have any questions? Want me to look at it with you, or everyone just keep working? Just let me know. All right. If you need me to go back to an old slide to show you syntax, let's get back really quick. Sorry? Yeah. This one? All right, perfect. I know I also used if statements on the variable slide, so you might have to use an if statement in there. So there's syntax for that. All right, I'll give you guys about one more minute and then we'll bring it together and just see where everyone's at. All right, anyone need more time or good to go over a solution together? Good. All right. So I'm just going to pull it up. Again, I'm just, writing JavaScript in this online interpreter. And I'll work through the example with you guys and we'll see if you get the same thing. So following the syntax from the slide, we're going to create a function. And our function's going to return the list of all numbers greater than 10. So I'll just call it greater than 10. It's going to need to take in a list of numbers. So I'll call that nums. Then inside the function, we're going to need to create a new list of numbers to return. So I'll call that nums greater than 10. And I'll set that equal to an empty list. And then we're going to go through the input list and we're going to check for each number if it's greater than 10. If it is, we'll add it to our new list. Then at the end of our loop, we'll return this new list we created. So useful for this is we can use that for of loop I was talking about. So we can do, say, for const num of nums. This is going to go through every number in the list nums. And inside this loop, we're going to check if its value is greater than 10. So if num is greater than 10, then we're going to add this to our new list. So num is greater than 10, dot push, that number. Then ideally, once this loop ends, we should have all of the numbers greater than 10 in the list nums greater than 10. So we should be able to return that variable. And let's see if that works. Compiles fine, so first I gotta call it. So I'm gonna print out result of calling greater than 10 on the list of numbers 1, 2, 45, 10, and 12. And then as expected, our output is 45 and 12. And just to check from that input example I gave, let's make sure we get the correct output. Perfect. We get 67 and 44. All right. Does anyone have any questions on the implementation here? Any differences between how you might have done it? Because you could also do this with a different kind of loop. You could have done a for loop where you just go from I equals 0 to I is less than the length of the nums list. Both are perfectly fine. All right. Let's get back to the presentation. All right, so next we have what are called arrow functions in JavaScript. These might be a bit new because these aren't really something you'd see in every language. So in JavaScript, there's the regular function syntax I was showing earlier, which is, you take in the input two numbers and return the sum. Arrow functions are nice. They're kind of like Lambda functions you might have heard of. And they can really shorten code a lot. Helps you write like anonymous functions that maybe you're not gonna reuse. You just want to be inside like a higher order function. So here, this actually accomplishes the exact same as the above in one line in a much more concise manner. So this can help improve code readability a lot, and arrow functions actually come in very handy when coding in JavaScript. There's a lot of times where you call a function and you want to just take in the parameters and do something with it, and you don't want to write this massive function every time you do that. All right, any questions on arrow functions? Sorry, is that a hand or no? Sorry. And we also have objects in JavaScript. So for example, if you wanted to create a restaurant object, you would create the open curly braces. And then you'd have a set of key value pairs in your object. So you have name is set to the string best burgers. The owner of our restaurant is Jane Doe. Opening year is a number, 1995. And then the menu items is just gonna be a list of strings. In this case, Best Burger serves burgers, shakes, and fries. So if you were to log out to the console, the value of the value stored at restaurant of opening year, this will return the value corresponding to the key opening year, which returns, sorry, not a string, that'd be the number 1995. Any questions on this? So another big thing in JavaScript is called asynchronous programming. And this is really useful. Essentially what it means is synchronous programming, each line of code is executed one at a time. Whereas in asynchronous code, you can actually execute multiple lines of code at the same time, which is really useful when working on the web because some processes can take a really long time. You don't want to have to put off everything else while you're trying to load different elements in the web page, or if you're trying to fetch data from a resource, you may want to do other things while that's loading in the background. Or if you're trying to write to a database, maybe you want to perform other lines of code instead of waiting until that process is done. And so this comes in very handy when working with things on the web. To give you an idea of how JavaScript accomplishes asynchronous programming, you use something called promises. The promise is essentially JavaScript object that says it is promising it is going to either return the resolution of a process or it's going to fail and reject. So this is tying into the asynchronous programming of, let's say we want to do something, but we want to move on and execute more code while it's running. So this promise is going to run and there's a resolve and reject function. And in this case, because the variable is Sunny is true, this if statement is going to evaluate to true, and it's going to resolve with the message it's Sunny. So you could write code that can either wait until this promise is completed and execute after, or you could write code that would occur at the same time. In case this process would take a long time, it would let you write both those lines concurrently. And in this case, this line would never run, but you could reject with an error if that was the case. Show you a bit more how to work with promises. So sometimes let's say you take the promise object that we just used from the last slide. There's a useful keyword in JavaScript called .then, which allows you to wait until a promise is resolved. It takes the result from that promise, and then it does something with the result. So in this case, my promise.then will wait until all this code executes, and then we'll log out the result. This is useful because if you are, for example, fetching data, that may return a promise, and so you need to wait until that promise is resolved, and then take the result of the promise. So the then keyword is useful for waiting for the result of something you need to be finished before you want to run your next line of code. And I didn't add .catch, but after that, then you can also do a .catch to catch in case it rejects. All right. Another part of this asynchronous programming are the async and await keywords. So we have this function here which returns a promise. And this promise, all it does is it resolves after 2 seconds. So this set timeout function just says execute this line of code after 2000 milliseconds or 2 seconds. So what's happening here is when this function is called, after 2 seconds, it'll return the result resolved. So then what you can do is, let's say this promise was fetching data or something you have to do to load your web page. You need to fetch some data, and then you're going to put that data into a data visualization. So what you need to do is you need to use the await keyword to wait until that function is completed, and then you can use the data. So you can only use await keywords inside async functions. So to do that, you just declare async in front of the function. Then that means you can put the await keyword in front of any sort of promise that you want to wait for the result before you execute your next line of code. The reason this is so useful in JavaScript is because it's very common for loading resources or fetching data to be these long processes, and it happens a lot. So it's very important sometimes, because if you didn't wait, when you log out result, you would just have a null value, or you'd have a promise that is pending. You wouldn't actually have the result of the value, so you wouldn't actually have the data you want. So for example, if we were to call the async call function right here, that would set result equal to the result of the resolve after 2 seconds, 2 seconds function, but it would wait until this promise was resolved to enter the next line. Yeah.
So is it like a pause following the line that is like eight or?
Right, exactly. So in this function, it is just going to sit and stop and not continue until this return value is resolved.
So anything you want to run asynchronously, you have to put
Right. So, well, you can run, for example, if you didn't put await and you just called that, this console.log would run asynchronously at the same time as that function. The reason in this case we don't want that is because then you would print out result before you even have result because you weren't waiting till it's completed. So if you get rid of await, it will actually run asynchronously because it'll execute this line and then the promise will take 2 seconds. And while it's executing that promise, it'll continue to execute the next lines of code. And so the reason we added the await is because in this case, we want it to execute synchronously.
So, but if you had like other pieces of code
In front of it. So first it would run, so like if we had other lines above const result, first it would run all those lines and then it would get here and without await, with await, it would complete all those lines. Then it would execute this line with await, and then it would, everything after it would wait until that's completed, not before, correct? Yeah, promises are built into JavaScript. That's their core. It was actually, they were introduced something called like ES6 syntax in like 2015, 2016. They used to have a different process and there was something called like callback hell and people got really stuck. So promises were their way of making it easier to wait until something's resolved and get the new information. But yeah, it's built in. When you fetch data or do something, it'll actually return a promise. So that's actually the built-in object in JavaScript. Yeah, because so like, for example, if you need to fetch something across a network, there's a chance it could fail. And so you need to have, you know, in case it's not successful, you need to be able to reject that and give the error for the reason why it failed. Right, like if this rejected, what would happen in here? It would actually store the error in here. So we go back. This creates a new error object with that message. And so then you just end up with the error object being in result. And this would just print out the error. Right. So typically, so like what a good way to handle it, which I forgot to show, but like I said, there's the .then, which is useful with promises because first you call the promise, and then once it's resolved, it executes this code. You can also add .catch, which only executes when it rejects. So that's an easy way to handle the resolve and reject of a promise. You put the code you want on resolution in the .then statement, and you do .catch for all of the code if it rejects. Any other questions? JSON. All right. So there's something called JSON or JavaScript object notation. And this is a text format for representing structured data based on the JavaScript object. You notice it looks super similar to the object we had a couple slides ago. The difference is all these keys are in strings. So JSON is a super popular data format, just like you might have heard of CSV or other kinds of formats. And I'm actually going to show you an example later on. We're going to fetch some JSON data and turn that into a visualization. But here, yeah, otherwise it looks basically the same as a JavaScript object. It's just it's kind of a standard for storing that data and retrieving that data. Any other questions on JSON? All right. So I'm going to go through a little data visualization actually in the browser with you guys. If you want to follow along, if you go to that link right there, I put all the starter code, which is where I'll be at as I'm starting. It's all in a public repo. So if you know how to use GitHub, you can pull that. If you don't know how to use GitHub, just go to that link and you can just manually copy and paste. There's like 1 or 2 files. And then you should be able to follow me through the rest of the entire workshop. So feel free to either, go to that link and follow it or just watch and follow along. There'll be a recording so you can always watch it later. give you all a second to get there. And let me know if anyone has any issues opening that link or finding the files. My bad. One sec. There we go. Once you do go to that link, it should take you to computer loads. Come on. Here we go. So check it out. That should take you here, which is the public GitHub repo I created. The only files that when you're doing, you worry about the README. So these are the 3 files that have the data you want. Index.js is empty, so if you want, you can just create that on your own. So is there any problems with accessing this or copying the files? Is everyone okay? All right, perfect. So what we're going to be doing here is we're going to be fetching some data and then turning that data into a visualization in the browser. This is very common for a lot of data scientists because the people often want data like dashboards in a way that people who aren't engineers can view. And so that's often in the form of a website. So it's very common that after you do all of your analysis and create your visualizations, you'll need to display them in a website for different kind of employees and industry in your company to view and understand what's going on. So I found this data set's pretty famous. It's called the Iris data set in JSON format. Found it for free. Kaggle is a website where you can just get a ton of different data sets. So I was able to just download this. As long as you get that file right here, that's the downloaded data. So you should be good to go. And I'll pull up the VS Code. So just to give you a quick glance, this workshop isn't on HTML, so I'm not going to go too in depth on what this file is. So no, this is defining the basic structure of our web page. And we're just creating a canvas to draw our visualization on. For now, that's all you really need to worry about. We'll do a workshop on HTML and CSS in the future, but today we're just going to focus on the JavaScript side. So looking at the data set we have, it's called iris.json. So here's a real world example of JSON data. It's a list of objects. And if you look at it, it's about 150 objects. They store different information on irises, including the sepal length, width, petal length and width, and then also the species. And you'll notice in this data set, there is 3 species. There's the Setosa, versicolor, and the Virginica species. So what we're going to do is we're going to create a basic data visualization comparing the petal width of the different species and seeing if there's a correlation between species and petal width. Any questions or problems so far? Is everyone good to go with index.js? All right, perfect. So the first thing we need to do is get that data, because again, this is all going to be ran in the client side on their browser when someone opens up the website. So there's a function built into JavaScript called fetch, and I'm going to fetch that iris.json file. And again, this is going to, as I was talking about earlier, this function is going to return a promise. It's either going to successfully get the data, and it's going to return the data, or if it fails, it's going to reject with the error. So what you can do here is you can, using the then syntax I was talking about earlier, say .then, and you take the result of that fetch, which will wait until the promise is resolved, and it will take the result. And we're going to convert that to result.json. This is just a built-in JavaScript function. Don't worry about it. This is going to give us the data in the format that we want. I'm going to do another .then. So after we execute that first then, and I'm going to take the iris data, and I'm just going to console.log it out to the screen. So we should be able to see our data. Any questions on what I'm doing right here? All right. So another thing, if you are using VS Code, and you want to actually see this website running on your own computer, there's a really cool extension in VS Code called Live Server. So you could probably go and install this right now. It'd take you a few seconds to install. And what Live Server lets you do is it lets you run a development server on your local computer that auto updates as you save the files. So it's super effective if you're trying to just maybe make small tweaks to your website, and it will just live show all the updates. So if I start a live server, it'll open in my browser. Go to folder we're working in. And we haven't put anything on our webpage yet, but we did log out the results to the screen. So you'll see here, this is that iris data from the JSON file. It's an array of 150 elements. Here's the first 100, and then here's the last 50. And the way you open up this panel is if you do Control-Shift-I or Command-Shift-I in Windows. This is called Chrome Developer Tools. And this is where the console actually is. So every time you're saying console.log in JavaScript, you're printing out information to the console in their browser. All right. So going back to our code. Now that we have that iris data, we need to try to break it down in a meaningful way so that we can create our data visualization. So what I'm going to do is I'm going to try to separate the data into by species. So like first, we're going to have the Setosa data. And that's going to be the first 50 elements of our iris data, because if we look at it, it was a 150 element array of objects, and the first 50 were Setosa, the next 50 are versicolor, and the last 50 are virginica. So to do this in JavaScript, you call the slice method on the data, and all that does is it just takes all the entries from the start to the stop. So in this case, if we go from 0 to 50, that'll take the first 50 elements from the array iris data. Any questions on that? All right. So let's check out what that is. We log out Setosa data. Go back to our website. Now you'll see it just prints out that list of 50 elements, which is all of the Setosa irises. Yeah. So in VS Code, if you click this box here, it's extensions, and then you download Live Server. Then in the bottom right here, you'll see, I can actually close it, and you'll see right here it says go live. And if you go live, it should automatically start the server at a local port. And then in this case, I started in a different directory, so I have to click the directory I want. And now it appears. Does that work for you? Okay, cool. All right. So now that we have that Setosa data, the plan for our analysis is we're going to try to graph the difference between the petal width and the species. So first, I'm going to try to get the average petal width for the Setosa species. The way I'm going to do that is I'm going to set a variable. It's going to store the average. So I'll let Setosa petal width average. For now, we're just going to set it equal to 0. Now we're going to use that for of loop we were talking about earlier to iterate through the Setosa data list and then add up all of the petal widths and then divide them by 50 to get the average. So for const iris in iris data, or of iris data. So again, this is just going to go through iris data, and it's going to assign each object one at a time to be in the variable iris. We're just going to add the petal width, the value of that object, of the petal width of that object, to our average. So we'll say Setosa petal width average plus equals, which is the same as just Setosa petal width equals plus whatever this value is. Yep. I did. Thank you. Good catch. All right. And then going forward, once with this average, we're gonna add the petal width of the current iris. So when we access that, is we take iris of petal width. As if we look at our JSON, each of these is an object. So to access the petal width value, use this syntax with that key petal width. Now, getting out of this loop, we should have the sum of all of the petal widths for the Setosa data. So now to make an average, we're just going to divide by 50. So the Setosa petal width average, again, divide equal is just saying divide by 50. And then let's print that out to the console and let's see if we did that correctly. Sweet. All right, well, that's a number. Let's see, 0.245. Looking at the data, does 0.245 seems reasonable. Most of the data tends to be like 0.2, 0.3. So now we have to do that same thing for the versicolor and for the virginica. So I'm just going to copy this code. I'm going to copy this code right here. I'm just going to do this 2 more times. And this time we're going to replace this with the versicolor. And this time, because we don't want the first 50, we want the next 50. So we're going to go from index 50 to index 100. With this slice command, the first parameter is inclusive. So it's going to take the one at 50, and then a 100 is exclusive. So it's going to take up to the value at index 99. Here's the color. Changing the variable names here. All right, so that should be the versicolor. And then we got virginica. And for this one, we're going to go from 100 to the end, which I believe if you just put in one parameter, it'll go from that start all the way to the end. No, I'm going a bit fast, sorry. Just copy and paste that value over and over, just end up with the same thing. We want to just test to see if that all worked. I'm going to print out to the screen the Setosa data, the Setosa average, the versicolor average, and then also the virginica average as well. And let's see how that appears on our website. All right, so it looks like there's a pretty big difference in petal width based on species, 0.245, 1.325, and 2.026. So now that we have that data, let's actually create a data visualization so that people can draw some more meaning from it. So the exact syntax for this, I just saved in a file, so I'm going to copy it and talk you guys through it. This is using a library called chart.js. I've used it before. It's just a JavaScript library for creating different kind of charts, bar charts, scatter plots, stuff like that. And all we had to do, and it wasn't to include this, was in our index.html file, I added this script tag to add a chart.js. Now, what this is doing is this is going to create a new chart. It's going to assign it, it's going to put it in that canvas I created in our HTML file. And it's going to create a bar chart. The data for the labels is going to be our 3 species. The data set is using those petal widths that we declared earlier. Although it looks like I used a different name then, so average. This here is defining the color. And then we specify a few different options to make it all look the way we want. So if I save that and go back to our website, you'll see we have a full data visualization in the browser that is plotting the iris petal width by species in centimeters. And it's pretty clear there's a pretty significant difference between Setosa, versicolor, and virginica. You could run a data analysis to see how significant that is, but for the purpose of this, show JavaScript, Just wanted to show you how it's possible to create a basic visualization in the browser. And using this, you could create like a bigger overall dashboard with a ton of different information on different attributes that you find important. Are there any questions? All right. So now that we have that completed, this is the final result I wanted to show you guys. So this is the end of the JavaScript workshop. I want to thank you guys for coming and I hope you have a great day. And please come up if you have any questions or want to look through anything else, please let me know.